Now we will look on to the next set operation, which is disjoint. Now what is disjoint? For that we need to understand using diagram. So let's say we have two sets. Um, let's take let's make another two sets. So here we have a set called X, and inside X we have A, B, C, and there is another set called Y, and inside Y we have I, J, K. Okay, so we have two new sets. Now look at them very closely. Does X and Y have anything common in them? No. Y has I, J and K, whereas X has A, B and C. That means no elements are common between them. That means the intersection of X and Y gives us none. Or we can say the intersection of X and Y gives us phi in mathematical terms. Now let's remove this section over here, and by just remove this part. We don't need this anymore. Just delete it. Okay, so now we have our universal set. That means we have all the elements inside this box. Now let's draw two sets, two circles. This is a circle and this is another circle. Well, I'm sorry, control C, control V. Why doesn't this work? Well, no problems, I'll make another one. So yeah, they both are circles and they both represent a set. So this is set X and this is set Y. Now X has A, B and C, whereas Y has I, J and K, right? Now, do they have any common portion? No, they don't. Because if there was a common portion, then there would have been, a shape like I, like this, and this would be the common section, right? This would be the common section, but that is clearly not the case, as you can see, because there is a distance between both of them, right? So they are no way intersecting with each other. So there is no eye-like structure, or there is no intersection. I'm sorry, let's remove it. Yeah, so there is no intersection. So these are the intersecting points. This is one intersection point, and this is another intersecting points. So there is no such points. That means there is no common elements between X and Y, and that is clearly visible over here. X has ABC while Y has IJK, and there is no common elements between them. So that means these are disjoint sets. And how do we write disjoint sets? Well, disjoint sets do not have a special notation, but we can write this thing. Let's just take a text and let's write X, Y, and again we say intersection, and intersection is just upside down U, and then again text right here equals, I'm sorry, equals none, or in mathematics you call it phi, or this symbol, this circle, and oh, I'm sorry, let's draw it again because I am bad at drawing. Yeah, so we use this symbol to denote that there are no elements, and where there are no elements, X intersection Y, that means there is no common portion between them. So this is the disjoint set. This proves that X and Y are disjoint sets for each other, right? Now let's move on to the next topic, which is set difference. Now for set difference, I have to remove this once again. Let's remove x and y. And let's go back to, well, yeah, okay. Now, again we have two sets J and P, and we have these elements. Now, what if I subtract P, that is this circle, this whole circle from J, that means this one, this whole circle, right? What will happen? So that means let's remove this circle. So let's, this shaded portion. So this is subtracted part. We remove it. We remove it entirely. We just remove it. So this is the shaded portion, which shows that we have removed the set and the elements of the set. So now what do we have? We have only D, E and F. We do not have B and C, right? We do not have this also. So no elements of P is present here, as well as we remove the common elements B and C because it is also a part of P. And when we remove P, B and C is automatically removed. Now you might say, well, B and C is also present in J, and that's my point. B and C falls into the common portion, and if you remove any one of the sets entirely, B and C will be removed. That's why B and C will no longer be there. So difference means that we exclude the common portions of one set from the another set, right? So that means we entirely remove this section. We remove B and C from set J. So now we have only three elements, D, E and F, right? So that means we take only this part. We take only this part. That means we take D, E and F. We do not take this part. We remove this. We remove this entirely. Okay? So these vertical lines indicate that we have removed this one. Just remove it completely. Yeah. So this is the portion we will need or we get, and we remove this whole section P entirely. Okay. So now we can denote this using a simple subtraction symbol. So we can write, we can say J minus P equals D, E, F. So as you can see, I have removed the common portion of J with P. So basically we are removing all the elements of P from J, and thus we get D, E and F. That means only these three only. We remove B, C and all of these. So that was the set difference operation. And the next operation is symmetric difference. In symmetric difference, this one is a tricky one, so look closely. When we talk about symmetric difference, we take this portion. Let me draw it. You can fast forward it if you want, because it takes some time to draw using just mouse pad. I do not have a mouse actually. I'm drawing using my laptop's mouse pad, so it takes time. I take this part and I take this part. So that's what we take. Okay. So D, E, F, A, H, I, J, K is what we take. And what do we remove then? You can clearly see we are removing this part. We are removing this part. And this is called the symmetric difference. In the symmetric difference between two sets, we take all the elements of both the set except the common ones. We take all the elements of both the sets, that means D, E, F, A, H, I, J, K, except the common ones, that means B and C. And you can prove it, symmetric difference is written like this in mathematics. You can say J, well, I need a triangle. Let me draw it later on. P, and let me draw a triangle here. Is there a triangle available? Yeah. Well, yeah. So I draw a triangle here. Oops. I'll remove it, just delete it. And to draw another one. Well, okay. So yeah. This thing is called J delta P. And J delta P is the is the symmetric difference operation. This is the symmetric difference operation in mathematics. And you do not have to do all this complex thing. You can basically write, this will convert to this thing, J minus P, and we will just give a union here, P minus J. And we put a union here. Oops. Yeah, so that is our union. So we basically remove P from J and then J from P and take both the elements. So in this case, well, let me take another color so that you can understand. So first we remove P from J, that means we remove this portion, this entire portion from J, that means we have D, E and F, right? And after that we remove J from P, that means we remove this entire portion and we are left with A, H, I, J and K. And then we do a union here. We do a union between them. So are there any elements that repeat? No. Are there any elements that are common? No. So we can directly write like this, equal to, we can say D, E, F, A, H, I, J and K. So this is the symmetric difference operation in sets. Moving on to the next operation, complement of a set. Now this is an easy one. Let me just remove this one. Let's take the selection tool and remove again all of these things. Delete it. Yeah. Now let's take a set. Let's take R for example. Right? Let's draw a circle here. Let's make circle be, I'm sorry, I don't want green, in fact I want a black one. So we have a big circle over here, and this is set R. So we write R over it, and it has A, B, K and E, right? It has A, B, K, E, and this outer portion is the union set. So inside union sets, what we have? We have all the elements from A to K. So we write this as, A, B, C, D, E, F, G, H, I, J, K. Okay, so we have these elements. Now when we are doing a complement, all we have to do is take all the elements except the elements inside the set. So inside R we have A, B, K and E. So other than A, B, K and E, what are the other elements? And we can search it from the union set, and that is this one over here. So if we remove A, B, K and E, we are left with C, D, F, G, H, I, J, and that is our complement. So basically what we are doing here is we are taking all the elements except the elements of the set itself. So we are taking all the elements except these one. Okay, so we are basically taking all the elements except A, B, K and E, right? We are taking only this. But here is a good concept. These things are already inside this, right? A is already present in R, B is already present in R, same goes for K and E, right? K and E as well. So these are already here. These are already inside set R. So we won't write these. We won't write these in the outer circle. So let's remove it. Let's take the selection tool. This is just for understanding, you can do it manually. Remove this and write it again. So we write C, D, F, G, H, I, J, right? Because we already have these elements inside R, this is already present inside here. So we don't need to write it again. That would be a mistake. So when I say take the complement of set R, I mean take all the elements in the situation except the elements of R. I repeat once again. When I say take the complement of R, I take all the elements of U except the elements inside R. So I take C, D, F, G, H, I, J, and I can write this in mathematics. I write this using this R well okay, R equals, just leave it and take a line and make sure this, yeah, that's it, perfect. Okay, a little bit smaller, yep, that will do. Yeah, so this is called the R complement. So R dash, okay, so this is called R complement, or R complement can also be written using this. Both are the same, so don't get confused. R, and again take a line and give a bar over its head. So they both are same. You can choose whatever you like. Now I write C, D, F, G, H, I and J. So that is the complement of a set. And using diagram I can say I take this portion. I take this whole portion, or well, let's paint it. Okay, let's paint it because it becomes difficult. Yeah, paint option, use light color. Yeah, so I take the pink portion. I do not take the white portion. Okay, I remove the white portion. I take only the pink portion. I hope you got it. That was the complement, guys. Is there anything left I can teach? Well, congratulations. All the topics are completed theoretically. Now I'll be showing programs in Python, And for these purposes I will use another thing which I think you guys need to know. If you are Windows, then you should use something called Python IDLE. It is already installed when you had installed Python in your system, and if it is not, you can install it from internet. So type IDLE and you see this one, IDLE Python 3.8 or whatever 32-bit. So let's start it. So now we will work with sets in Python. So now you guys know the theory behind sets, because I have shown that in really interesting and exhaustive way. So watch that before you continue. Okay, watch it again if you want to. After that you may continue. Now we will see how to use sets in Python. So how, I mean, the first thing we should learn is how to define a set in Python. So if we want to define an empty set, we can use this. Let's say this is the name of a set, and we can say set. So A is a set. A is an empty set. As you can see, A is an empty set. There are no elements inside A. But what if you want to declare a set with many elements? So if I say A equals, now you put these brackets, these curly brackets, you know, these brackets, and put all the elements separated by a comma. So let's say 1, comma 2, comma 3, comma 4, comma 5. Okay. So now if I say hit A, we get 1, 2, 3, 4, 5, and we can check the type of A. So you can see it is a set, right? Now let's have some experiment and some fun with set. So you can check out the theory and you can verify it here like this: 1 comma 1, 1 comma 1 comma 1 comma 1 comma 1 comma 2 comma 2 comma 2 comma 3 comma 4 comma 4 comma, I'm sorry, 4 comma 4 comma 3 comma 3. So we have 1 comma 2 comma 1 comma 1 comma 1 and all those repeating stuffs. Now once I hit enter, you may think all the elements are inside A, but when I hit A, see, we have only 4 elements: 1, 2, 3, and 4. That means the repeated elements have been removed, and that is the specialty of sets, right? So all the repeated elements have been removed, and that is the main purpose of set inside Python. Remember that, and we will come to that, and we will see how to convert, from set to tuple, from list to set using tuple, and all those stuff later on. Just hold on. And first, let's do some set operations we have seen till now. So now let's have, let's take the old good example. So we have, let's control Z everything. Yeah, perfect. Let's control Z all the things. Now we can, yeah. So now let's take this one. This pencil is bad. Yeah. So we take this one, right? U. So let's have a set called U. I'm sorry. Open this. U is a set which has elements A, B, C, D, E, F, G, H, I, J. Okay. And remember to put the quotes, because without quotes, these will be treated as variables and you will get an error. So these are just string letters, strings. So every time you use string, put it inside single quotes or double quotes, it doesn't matter, but put it inside quotes. I'm sorry. As you can see, I missed it, and it gave me this error, name error. So name A is not defined, so it treats A as a variable, and that is bad. So let's write it again, and I'm done. Now what are the contents of U? So the order has been changed, because order really doesn't matter. F is here, J is here, it really doesn't matter. Okay. So set doesn't work with orders. Now let's take another set. Let's take a set called A, and let A have A, A, B, and C. Now I can write A dot, and you hit tab, and this is the specialty of Python. Ideally, you can see all the different methods of a particular object, or particular data types. So these are the methods. Now we will use is subset, this one, and inside is subset I say you. You can see it gives us true. So we are checking, is A, this set, a subset of U? That's why we are asking set, and we can, is subset. So this is what we are asking, is subset. We are saying, is A a subset of U? And it gives us true. Now we can see A dot, and I said disjoint U, we get false. Is A disjoint set? Are A and U disjoint sets? No, because they do have a common portion, and that is A, B, and C, because obviously A, B, C are part of U, and so A is the subset of U, and A and U are not disjoint sets. Now I can say A dot is super, I'm sorry, set, and you say U. So we are saying, is A the superset of U? No, obviously not. A is the subset of U. But if we say U dot is superset A, A, we get true. So we are saying, is U the superset of set A? So obviously, if A is the subset of U, then of course U will be the superset of A. And that's why it gives us true. Let's check the other methods. So we have add, clear, copy, and many of them you actually do not need. But let's start with union, our good old union, but for that we need another set. So let's have a set called B, and let B have A, I'm sorry, A, B, I, G, H. Okay, so that is our set B. Now if I say A dot union B, and you can see the feature of Python. Ideally, it gives you a brief introduction of the method, return the union of sets as a new set. So it gives you a brief summary of what the method can do. So I say A union B, and see, I get all these, C, A, I, B, G, H. So let's check if all the elements are present. So A, B, so A, B, I, G, I, G, and H. So now we have H. And when we check A, do we have A? Of course we have A. We have B. Yes, we do have B here. And what about C? C is here. So this is the union. Similarly, if I say A dot intersection, and I say B, I get the common elements between A and B. So what are the common elements between A and B? It is A and B, right? Now there are other methods. A dot tab, and I say okay, I have shown you discard. So let me show. So what are the other methods? Let's say yeah. So set difference. So set difference is actually, let's see tab, and is there a difference here? So now this is the symmetric difference. Yeah. So we have the difference, right? So return the difference of two or more sets as a new set. So I say B. Notice. Oh my god. Oh my god. Okay, it works in a different way. Let me show you how it works. So A difference B gives us C, and let's check it out why. So okay, yeah, it's perfectly fine. So basically we are removing the common parts of B, that is A and B is already present in B. So we remove A and B from A, and all we are left with is C. Yeah. So we have C. Therefore, now it will be same if we do B dot difference and we say A. See what we get. So we basically remove all the common elements with A. That means A and B. So once we remove this one and this one, we are left with C, I, G. I'm sorry, what's happening? Oh, I'm sorry. This is not the thing. So once we remove the common elements of A, which is A and B, we are left with I, G, and H. Okay, I'm really sorry. Now let's check another thing. So if I say B dot and let's do symmetric difference this time. Let's say A, hit enter, we get C, I, G, H. So we get all the elements of both the sets except the common ones. So C is unique for set A and I, G, H are unique for set B. But the common part was A and B, which has been removed completely. So this is symmetric difference. Coming back to our point, is there anything else to show? Complement, I guess complement is not available, right? Without. Okay, so complement is not available, but you can of course do it. The complement of B. So what is the value of A? So C A B. What is the value of U? All these elements. Now, if we want to find out the complement, we basically say U dot subtract. I'm sorry, difference. Is the difference one? Yeah. U dot difference from U remove A, and now we have our complement. So this is actually complement because we are removing A from U. We can directly write U minus A, and we get the same thing. So you can actually interchange with this to this. I prefer this one because this actually prevents confusion, but this actually causes confusion. But that's up to you. You can use any one of them. For union, I can say, okay, so what is set B and what is set A, and I want to do a union, I can say A pipe B. I can see CAIGBH. So A dot union B, A dot union B is same as A pipe B. This is A union B. This is also A union B. You can use whatever you want. Now again, A dot, well, A dot intersection B, so we get A and B. We can also write A and B. So these are same. A dot intersection and A and B are same thing. You can choose whatever you like. So this is how you play with sets. So I have shown you all the concepts. I have shown you symmetric difference. I have shown you difference. I have shown you disjoint sets. Now let's take two examples of disjoint sets. Okay. So let's take a set X which has A, B, C. Oh, I'm sorry. A, B, C, C. And another Y equal, well, what can I take? I can say GHI, G, H, I. Perfect. Now if we check X dot disjoint, I'm sorry, disjoint I'm sorry, there is disjoint, yeah. X is disjoint B, I'm sorry, Y. So yeah, true. So we are asking if X and Y are actually disjoint sets, and it is actually true, so there are no common elements, right? And we can verify this saying X and Y. So X intersection Y. So yeah, since it has no elements, it says set without any elements. So these were the set operations, and I have shown all the methods. Now some other methods as well. Let's have set A. So set A has three elements C, A and B. Now if I say A dot, let's hit tab, add, and we can add another element. We can say 9. See, we have, I'm sorry, what is this now? Yeah, 9CAB. So 9 is also a string, remember that. I can say A dot add H. Now check the elements of A. We have 9CABH. So we can use add to add individual elements into the set. Now there are also other methods. A dot pop will remove the last element, just like list or tuple. I'm sorry, no, not tuple, list. So we removed this one over here. Again A dot pop. So it is removing from this side. So first element was removed 9, then the next element removed was C. So now if I check the content, you can see it is A, B and H. So since we have removed both of them, we have only A, B and H only. Now let's take other methods as well. So clear will remove all the elements and it will become an empty set. Now there is discard operation. Remove an element from a set if it is a member. So if I hit B, Now if I check A, see, everything is the same because lowercase b was never a part of set A. But if I say the same thing with capital or uppercase B, let's say discard B, so you can see B has been removed. So use discard whenever you want to remove an element. But if there is another alternative for discard, and it is sometimes used although, and it's called remove. I guess it was remove or what? Yeah, it was remove, right? So remove an element from a set. It must be a member. Focus on these words. It must be a member. So if you write something, um, anything which is not a member, it will give you error. It will give you this error, key error B. It is not present. It is not a member of set A. But if you say something like this, A dot remove, and you say H, it is removed. See, A has only one element, and that is A itself. Now, what else can we do? Is there anything else? Let's say tab. So we can do a copy. This is basically, copying things, copying the set itself. So we get a copy of set. So these were some of the, okay, update. This one is important too. Update a set with the union of itself and others. So let's see what you can do. We have a tuple in here, 1 2 3, and let's see what are the elements now. So we add elements of this tuple into A, and this is not the same as this. Let's say A dot add. If I want to add the whole tuple as a single element of set, I would use A dot add, and I will say, well, 1 comma 2 comma 3. Well, this won't work because 1 comma 2 comma 3 is already present. Well, maybe this works. Let's see. Well, yes, because yeah, it works. So you can see when you said update, it inserted the elements individually inside the set. So you can see 1, 2, and 3. But when you said a dot add and you gave this tuple, it added it as a whole. It is treating them as a single element. So if you are thinking that the length of the set is 1, 2, 3, 4, 5, 6, and 7, then you are wrong, because I can check it using length as always, and then check A, and we get 5. Why 5? Was 1, 2, 3, 4, 5. And remember, we cannot give everything inside here. We can only give immutable things. Now remember, a set cannot contain a mutable object. So let's say we just pass something, let's say add, and I gave a list. Let's give it a list. Let's say 3, 4, 5. So this is a list. So it gives us error, unhashable type list. So that means it cannot add mutable elements into itself. Although it is set itself is mutable, but it cannot add mutable elements. So let me say that again. Set itself is a mutable object, but it cannot add mutable objects. So this is a very important point. Remember this. Set itself is a mutable object, but it cannot add mutable objects. Set can only add immutable objects. Let's see what happens if I say a.update and I give this a list 5,6. I'm sorry, 5 6, 5,4. So see, it does not give any error because we are using update method, and update method takes each element out of the list and puts its put itself inside it. It does not take the whole list, but add was trying to add the whole thing into set, and that's why it gave us error. But update method only adds the single elements individually. So that is the difference, guys. Now we have covered all the important methods, although not all, but most important ones which we need in sets. Now time to show you conversions. Now let's say you have a list. You have a list here, and let's make the list demo list, and you have 1 2 3 4. Okay, 1 1 2 2 3 3 2 3 4 4 4 4 5 6. Let's say you want to make this thing unique. That means you want to remove all the duplicate elements from here. So you may say, let's convert it into a set, and that way we can remove all the duplicate elements. You are right. But when we try to do this, set demo list. So whatever we pass inside the set function becomes set. That is the concept. But you see, all of it is removed. Demo list set demo list. So now you can see we have all the unique elements, right? We have all the unique elements, but you didn't get it in a list from a list format. So what you can do, you can do something like this. You can say demo list, or let's take this example once again. So this is a list, and we are putting it like this, and let's say we are saying demo list equals to set demo list. So we are converting this list into set for making it unique, but then we are converting this back into list, so we are making this list again. See, we have 1 2 3 4 5 6 in a list format. Now let's open the Python interpreter inside our command line, the old good way. Let's have a list again. Demo list. We have 1 2 3 4 5. Well, not 1 1 1 2 2 3 3 3 3 3 5 5 6. Demo list equals to set demo list. So you can see it works. I'm showing this because you do not feel confused while using ideally and command line. Both are the same. Okay, now you can again convert tuples to set. So let's say there is a demo tuple, and it has got things like 1 2 3 4 5, then 5 5 5 5 5 5 5, then 2 2 2 2 2 1 1 1. oops, demo. Yeah. So we have our long tuple, and there are repeated elements, and we want to remove it. So what can we do? What can we do is we can say demo tuple equals set demo tuple. This would remove all the duplicate elements because it becomes set, and then we convert it back into tuple. So we convert the set back into tuple. So we see we get our demo tuple, and now all the elements are unique. Now some more tricks. Let's say you have two lists. Let's say you have a list called A, which has elements like, you know, let's say, okay, remember the game we made, choices. So let's say there are two lists. Let's say my favorite color is red, my favorite food is burger, um my favorite animal as a pet is dog. Anything else? I cannot recall the questions. Yeah, our favorite TV show is Lucifer. And there was, okay, let's say there is another list B, and that person's favorite color is blue, and he loves to eat burger, and his favorite animal is cat. I'm sorry, cat, and he watches Friends. Now remember all those logic, those for loops which I used, that zip function which I used to to see which elements do match. Remember that? But we could have done it very easily using this one. Set A, and that means intersection, set B, and then convert the whole thing into a list. So you say list. See, you get the common element, burger. That means this element is same, right? So now we can easily calculate the percentage because the total length is 4, where the length of this list only 1. So that is 1 out of 4 multiplied by 100, and we get our percentage. So that is, one trick. So this is a common sense that you can use all the methods of sets into tuples or lists just by converting them, right? So you can convert them and you can do intersection. Let's say you have a list called A again, and you have 1, 2, 2, 2, 2, 3, 4, 4, 4, 3, and then you have a list called B which has well, 1, 2, 3, 4, 5, 6, 7, 8. Okay, now these are the two lists. Now I can perform intersection, I can perform union, I can do set difference, I can do symmetric difference, I can check if these are subsets or superset. Okay, I can do all of those stuff just by converting them. So I can say set A, now A is a set. Now I can say, well, set A dot, now you will say that, let's say union, and B. So B was actually a list, and we convert B into a set, and then use the union method. Let's see if this works. So as you can see, this works perfectly. Okay, and we get the expected result. In the same way, we can say set A dot is subset set B true. So you can see you can do all the things that you could have done using sets. You just convert the list into a set, then use the method, and then again inside the method you pass the list by actually converting the list into a set. So that was the trick, guys, and you can do the same thing in tuples as well. Now you can loop through set just like any other iterables. For x in range, okay, not range, for x in, well, B, first let's make these set. Okay, let's have a set, and I'm pretty sure you guys can figure it out by yourself only. I don't need to show it, but still let me show it. For x in A, print x. So you can see it works similarly like it worked in lists, right? So it is the same basically. So these were the tricks, guys. Now let me show my pretty face. Hi there, good morning. Actually the video was a 5-part or 6-part video, so I'm recording this in the morning. Hi guys. So the video is completed. Now you have learned one very important thing. You can use various methods of other objects into some other objects by actually converting it. Now that is called type conversion. You can do it, and you can actually use the methods of another objects into your own objects, or into another objects. Let's say you use the methods of set into a tuple, or you can use the methods of set into a list, or you can use the methods of list into a set. You can do all those stuffs, okay, just by converting them. I've shown you how to convert it into a set, into a tuple, into a list, and then convert it back and forth, okay, between those things. So that was the video, guys. In the next video I will give you an assignment which will be based on a word problem, and the word problem will be very interesting. So solve it, guys, and write code yourself, and don't worry if you cannot, because I'm there for you always. I will give you the solution video after a few days, and then you can watch it, and then you can learn from it, and then you can implement and solve it, okay? So we have completed almost all the data structures. Now we have left with two data structures, that is strings, which we are going to cover next, and the next thing is dictionary. So these two things we are going to cover next. In the next tutorial we'll cover strings. So we will do some fun application with strings. We'll have much fun with strings, and strings are very crucial part of Python, and you will learn how to manipulate text and strings, words, letters, how to count each of them, okay? I will show you. So see you in the next video, guys. Till then, bye. Namaste.